Mustafa is actually a research scientist at Google Brain. And he was before a PhD student at the University of Amsterdam, so he has like a very complete overview of the Amsterdam ecosystem, I would say. And he's currently working on attention-based models. But during his PhD, he was also working on improving learning with imperfect supervision. And like, for example, in injecting inductive biases, incorporating prior knowledge, and meta-learning the properties of data from the data itself. And so I think we can maybe wait a bit more, or shall we start slowly? We can also start slowly. Mustafa, as you want, we can try to share the slides, and then I will
Can you
see
share
how
the
this goes.
slides?
It works.
Awesome.
I'm very excited because Mustafa has been one of the people I've been hanging around in Amsterdam for a while since he was a PhD student. So I think he will give a very good talk.
Right. Thank you very much. Thanks for having me. I like a few weeks ago, I actually so like Sarah and others, they sent me an email, and then they said like, would you like to give a talk? And I was super happy. I always want to basically promote the research and AI ecosystem in Amsterdam, because I truly believe that this is an amazing place and there are like a lot of opportunities. And I was like, okay, let me help. And then I sent them a like a title and abstract. And then yesterday I realized that it's a bit too much technical, like comparing my talk with other speakers. So I'm going to change it a little bit, but don't worry, I don't want to just like lose all the technical and scientific part, but want to go a little bit like back and take a look at the different projects that we are actually running in Brain Amsterdam. So at Google, the I again I don't want to be like all advertising, but again I want to emphasize on things that are important for myself, and maybe these are also something that you want to consider as like, I don't know, something that you would like to have in an environment that you would want to work in. So just sharing this information. So basically at Brain, uh, there are a few things that we actually really care about. Like the first one is that we really try to align our work and research with what matters for society and science. The other one is basically we want to work on research breakthroughs that are basically that are transferable, and they're like basically they can have impact on like products or people's life. So mostly working on directions that we can get some outcome and then push it into something that is visible for the outside world. And the other things that we actually really like keep trying to have it is like this bottom up culture of research in Brain. And while we basically target like a moonshot goal, we normally like work as individuals, and we try to extract our agenda for what we would like to work on, and then basically it organically grows into teams and groups that are working on like bigger projects. So in Brain Amsterdam, we are working on a few main lines that are basically like the mainstream of research. I'm listing those here, but they're not like, like the team is small, but if you just count like general directions that people are working on, they're like mostly can be summarized into these items. The first one that again I am a bit biased when I'm explaining about this, because I would probably promote or talk about what I'm involved in a bit more than other branches. But if you're interested in any of these, please reach out, and I can either explain more or connect you with the people who are in charge of these projects, and like get more information. So the first one is basically scaling up and building smarter neural networks. The second one is we actually have a team that are focusing on building neural weather models, like super amazing. I'm going to talk about that a little bit more. We also have a bunch of people who are focusing on generative models. Again, I have a slide to talk about a few of the works that they've been doing. Another focus of people in Amsterdam is basically working on ML research infrastructure. So you've probably heard about JAX and Flax or Scenic. These are basically machine learning libraries that researchers are using for developing their ideas. And we also work on reinforcement learning, and there are also projects that are like smaller projects that are defined on other topics. I want to talk about transformers a little bit and say how we are using transformers and attention-based model for smart and large-scale solutions. So transformers are like pretty amazing because they have this attention inductive bias that is super helpful for solving many problems. And compared to alternatives like convolutions or like other type of architectures, they have this global receptive field, which is pretty amazing. It gives them the ability to learn the contextual representation based on a wide range of information. They're parallelizable. So if you compare them with recurrent neural networks, they're like much faster. And if you check, you can see that basically like transformers, they're like taking over NLP, like natural language processing. And like recently in the past year, they're actually taking over the computer vision community by storm. So one of the things that we've been working on was basically applying transformer on computer vision. So this actually just happened by like having people who were working on transformers on natural language processing collocated with people that they were working on computer vision. And then we started actually playing with this idea, and we came up with vision transformer, which I think if you're working on computer vision, probably you would know about that. And it's like the whole idea is to take the image, extract patches, linearly project them, and then just add some sort of signals that gives some idea about the position of these patches, and then feed it to a transformer encoder, and then simply classify the output. So basically, it keeps the whole architecture close to the original transformer. The only thing is that instead of a tokenizer that operates on like sequence of word, we have this like patcher, or basically this patch extractor module that takes overlapping, like non-overlapping patches, and then embeds them into a set of tokens or embeddings. We realized that basically if you use vision transformer, you can scale them up like much more efficient compared to alternative like convolution models. And then right now, the state-of-the-art models for image classification and remote image recognition is basically a super large VIT, like VIT giant /14. Don't want to go to the details, but I just wanted to say that basically they are showing like super promising direction for both scaling up and also replacing the alternatives that we've been using so far. We didn't stop at image classification and basically working on images. We extended the ideas into different modalities. One of them is basically this like Vivid, which is a video vision transformer. And the idea was basically how we can use the same architecture on a sequence of frames instead of individual images, and then how we can basically reuse weights that we learn from like image classification task, how we can basically transfer the knowledge from images to videos using these type of architectures. And the target was basically like hitting the state of the art for video modeling and video action recognition. When we talk about the scale, you also need to talk about efficiency. So we've been also spending like a lot of time on discussing what architecture is efficient, what is good, like how we can make these like architectures that we want to scale up more efficient, especially for transformers. We have this quadratic complexity of this, the self-attention. So we've been also running a lot of analysis and basically like different, like we are benchmarking different variants that like the community together is coming up with to understand how we can find a better trade-off between this complexity of the models in terms of, I don't know, like flops or runtime or number of parameters versus the performance of the model in various tasks, like upstream task or any downstream task when we are doing transfer. You can also check, like we have basically a bunch of writes up. You can check like this efficient transformers, which is a survey. You can check actually this efficiency misnomer paper, which is just like right out of the oven. Like we actually put it on archive yesterday, and there are like a lot of interesting discussions about like how we can interpret efficiency of different architectures and different models. Another thing that I said at the beginning was basically not only we want to target models that scale better, but also they're smarter. So as we know, convolutions they basically process the input like input images as a grid of like pixels, right? So we basically sweep over an image in a grid style and then try to encode and understand what's going on in the image. But what is happening is that the world is not on the grid. So the amount of information that you can find in the sky here is probably less than the amount of information that you can find on, I don't know, like on the hand of this person who is walking across the street. While you have like, I don't know, 25 pixels here, and then you have like 200 pixels here. And then if you can find a way to distribute the compute to regions that are more information there, you can probably better understand what's going on. So if you can go outside this typical processing of the input images as a grid of pixels, you can basically not only better model the objects in your input, but also have a smarter way for spending your compute. One of the things that basically again came out of like collaborations also like from Amsterdam is this like object-centric learning and slot attention, that you try to learn this latent representations for different objects instead of blindly operating on an input image in a grid. We also have a lot of other applications. One of them, which is pretty fun, is this discretization transformer that it autoregressively generates the colored image, conditioning on the gray scale, gray, and basically a black and white or gray scale image. There are like many different things that we are actually using this discretization idea for example, augmentation. But these are all research that are already published, and you can just basically just track them down and find them. As I said, there is also a team that they're working on neural weather models. We all know bow and radar, but let me tell you, bow and radar is super helpful in Amsterdam. I know like all of you probably check them, and we are going to start checking them like from now until in the next 6 months every day. But they're not really good. We actually realized that this is good for like short-term prediction, but for long-term prediction, these models are not amazing, because most of the time they're like based on physical models of model of atmosphere, and for long-range predictions of rain, they're not really effective. And it's not easy. It is actually super hard to do this type of prediction, long-range predictions, because if you want to predict the rain like in 18 hours in like West Coast, you need to really understand the current state of the weather in as East Coast. So the input that you're supposed to process is extremely large. And you need to come up with an architecture that not only is effective in terms of modeling this whole complex situation, but also super efficient, because you're dealing with such a large input. I unfortunately can't share about like this project more, but there are like a lot of exciting things are coming, exciting things and outcomes are coming out soon. And this is one of the projects that I really like, and I'm super impressed by the progress that we made in Amsterdam. We also have a lot of people working on generative modeling. Unfortunately, I'm not expert in that, so I'm just gonna go over the list of work that people are working on. One of the main direction that people are extremely excited about at this point. So we've been working on flow-based model. People were working on autoregressive model and like variational models, but right now, what I know that people are super excited about diffusion-based generative models, and then if you check, you can see that there are like many different uh, variations of these like diffusion models are already out. As I said, like basically, I think like at least 1/3 of the team are actively working on this class of models, like variational diffusion models, somehow combining distillation with diffusion models, autoregressive diffusion models. And again, super exciting. Like a lot of cool results. And if you're interested to know more about this, you should definitely reach out to the team. They're also super excited about sharing all the results with the outside world. As I said, one of the missions that we also have in Amsterdam is also building infrastructure for machine learning researchers. I want to talk about JAX and Flax and Scenic a little bit. You might heard, like you probably heard about JAX and Flax, and you are wondering that is it just like a FOMO, or is it actually something nice? And if you should consider working with that or not, like is it going to be something like like if I work with TensorFlow, if I work with PyTorch, should I consider switching to JAX or not? I don't want to say the answer to this question, but I want to say that I'm extremely satisfied with JAX. So a little bit of advertisement: if you're not using it, consider checking it out. uh, Flags, so JAX is basically the main library for, it's not about neural networks, it's basically for doing high performance machine learning research. But Flags is a library that is based on top of JAX, especially for neural network. And Flax was born in Amsterdam, like Brain Amsterdam. It was actually organically, like one person started building this library, and right now that like many people across Google and outside are using Flax as the library of choice for developing their models and ideas in JAX. Flax is one of the biggest team in Amsterdam. They're actively working on improving Flax and contributing to the JAX ecosystem, and they're also growing. So if you are happy, or if you like to work on engineering challenges for machine learning infrastructure, you should definitely consider this. We also recently open sourced a library based on JAX and Flags called Scenic, which is designed for computer vision research and beyond. Please take a look. This is also something that was originated in Brain Amsterdam. Again, a lot of researchers are using this. This is actually one of the things that we are really proud of, being able to build tools that enables others to do awesome research. So in Amsterdam, in short, what I like about what is happening in the team is that we are actually working on cutting edge research. We're working on ideas that are on top of the basically they're like exactly things that are super hot, like challenging, and we're not working on something that was a challenge like a year ago for some companies, and this is pretty satisfying. Another thing is that we are constantly working on real world problems. So as you can see that, for example, this weather model, or different things that we've been working, there's actually a really nice way for pushing them into the products. We're also building in fantastic infrastructure that to enable everyone, not only in Google, but also in machine learning community, to do machine learning research. And also we have the chance of learning new things every day. We also have open positions. Check out the website, and please apply if you would like to work on any of these. And yeah, that's it. So happy to take questions or anything.
Okay, so thank you, Mustafa. It was a fantastic talk. I think I learned a lot. I think there is already a question from Dieter Odekotte. He's asking, how big is the Google Brain team in Amsterdam, if you're allowed to say?
Yeah, so right now the team, I think, is about like basically the research in Amsterdam. So because we also have a bunch of people who are working on research, but not part of Brain. But I think like research in Amsterdam is about 20 people, less than 20 people. We were supposed to grow, but because of pandemic, we had this hiring freeze. But we are having at least 3 more positions opening up soon, so it's going to be even more. But that's the size of the team.
Okay. I think I have also a set of questions that I'm supposed to ask you about. So one is like, I think you're originally from Iran, so why did you choose to come to Amsterdam in the first place? In the PhD stage already.
So, all right. So there are many factors, so some of
I
them
can imagine. Yeah.
are personal factors. But
Yeah.
what I want to say something that is not about like my something that is specific to me is that I really like Europe because especially like some city like Amsterdam because like many things are super optimized. One of them is like the speed of life, like the size of the city and everything is basically super optimized that you are not bored because nothing is happening and you're not overwhelmed because like there's too much happening. So in that sense, I found Amsterdam extremely optimized for living and also doing research. And I'm glad that it's actually getting better and better every day in terms of like the ecosystem that we're building for the work that we do.
Okay, and so I think for you specifically, the another question also happens is, I mean, you finished your PhD in Amsterdam, so you could have gone to US. You work for Google, right? So
Yep.
the main mothership is in US. So why did you decide to stay in Amsterdam?
Again, I think if you live in Amsterdam, you
Okay.
somehow get addicted to what is happening here, right? The fact that I can bike to work every day, this is like by itself is super amazing, right? And uh, I actually moved out of Amsterdam. Like I went start working from California, and then when I heard that there's actually opportunity to come back, I was like, oh, this is the best way to again go back to Amsterdam. So it wasn't like okay, I don't want to try something else, but I think I find it again super nice to be here, and the quality of the life, and given that we have the same quality of actually in terms of like the work environment and like smart people. So I think there's no reason to just leave. There's no positive side. Yeah.
Okay, I think there is a question from Ajay Kumar Tiwari.
Mhm.
And he says, hey, Mustafa, nice overview. Can you mention if the BREM team is also working on explainability and interpretability of models?
So we have actually a team which is called sub team, which is called PAIR, PAIR. You can actually check it out. We don't have
Okay.
anyone in person in Amsterdam, but there are actually also there are a bunch of people in London office. But we have one more person who is from the language team, not brain team, and she's working on interpretability. And I mean, if you just shoot me an email, I can send you that way, and then you can get more information.
Okay, fantastic. Unfortunately, we've chat for very long, but unfortunately, I think we have to continue. So thank you for your talk.
Sure, of course. Thank you very much for having me, and enjoy.
Okay, thank you.